Now I will share with you another method of inverse Laplace transform using the transform of integral. This is the theorems of the transform of integral, in which if Laplace transform of ft is fs, then inverse Laplace transform of the fs over s is equal to the integration from 0 to t f tau d tau. This means that the question of inverse Laplace transform must fulfill the format of this one. There is fs over s, at least it's divided by s. So we can solve using the transform of integral method. So we can say that the transform of integral can be used when s power of n is a factor of denominator and ft is the inverse Laplace transform of the fs, and it is easy to integrate. Now let's look at the example. By using the transform of integral, evaluate the inverse Laplace transform of 2 divided by s squared plus s. If you look at this question, we can actually factor out the denominator here. So inverse Laplace transform actually can be equal to s and multiply with s plus 1. We factor out the denominator. So, and then you compare with the transform of integrals. Okay, if you look at this one, inverse Laplace transform of fs divided by s, and this one also is divided by s. So what is the fs? Can you guess? So this part will be the fs. So from here we know that fs is equal to 2 over s plus 1. Okay, fs is equal to 2 over s plus 1, and then in this transform of integral that is equivalent to 0 to t f tau d tau. So what is the inverse Laplace transform of the fs? So we need to find out. So inverse Laplace transform of the fs is equal to 2, and then inverse Laplace. Okay, this 2 we can take it out, so 1 over s plus 1. This will equivalent to 2, and then this part we can change to exponent at equal to 1 over s minus a. Okay, we use this table of Laplace transform, so then we get 2 exponent minus t. So from here we can write like this: integration 0 to t, we follow the formula 0 to t, and then this f tau d tau is referred to the 2 exponent minus t dt. And then we integrate the 2 exponent minus t, so we get 2 exponent minus t minus 1. Okay, and we substitute the value of t and 0, so you get minus minus 2 exponent minus t, okay, minus with minus 1, so you get plus 2. And this is equivalent to 2 minus 2 exponent minus t. We just rearrange. If we leave like this, also can. Okay, this is using the transform of integral to solve, and we also can using the partial fraction. So actually the inverse Laplace transform can be solved using many methods. So the first one in this question is, in this example, is the transform of integral. Also we can solve using the partial fraction. So now I show you using partial fraction. So this one is all, okay? So the question is 2 over s squared plus s. So if I factor it out, I will become 2 over s plus a, s plus 1. So I split into a and b. And then I multiply this whole thing to the right hand side, or I move to the right hand side, so I get 2a s plus 1 plus bs. Okay. So, and I assume the s equal to 0 and also can x equal to minus 1. So I assume the s equal to 0 first. Then I get a equal to 2. Okay. Assume s equal to 0, so I get 0 here and I get 0 also, so I get a equal to 2. Then I assume s is equal to minus 1. Then what is the b? S equal to minus 1, so this one will cancel out. So this one is minus b equal to 2. So 2 equal to, and b equal to minus 2. Okay, so I can put, or I can substitute the value of a and b in the question. So inverse Laplace transform of 2 over s squared plus s will equivalent to inverse Laplace transform of 2 over s minus 2 over s plus 1. This is equivalent to, I take out the 2, okay, and I left 1 over s, and then I take out the 2 also, I left 1 over s plus 1. Again, inverse Laplace transform of the 1 over s, I get 2 only, I get 1 only, multiply with 2, I get 2, minus with, if this one, s plus 1, I have the s, I change to exponent minus t, because of the exponent at equal to 1 over s minus a. So if s plus 1, so I get the exponent minus t. That's all for this question. Then I move to second question. That is the inverse Laplace transform of 1 divided by s, and then in the bracket s squared plus 4. In this question, it's already in the form of a transform of integral. So this part is the transform of integral. But what we can inverse Laplace transform, what we can get this for this part? We can get nothing. But what if we inverse transform, we change the things? Like for example, s squared plus 4. This means it's s squared plus 2 squared. Okay, if s squared plus 2 squared, that must be sine or cos. Let's check the table. Okay, in this table we can see that s squared plus a squared. Okay, this one also s squared plus a squared, but for the cos it must have the s. For the sine is only for the a. So in this case, sine at would be more suitable to this question. Therefore, inverse Laplace transform of 2 over s squared plus 2 squared, this will equivalent to a sine 2t. So, to do this inverse Laplace transform of 2 over s squared plus 2 squared. Okay, this one is for the sine 2t, right? So we still have the s here from the question, but don't forget the 2 here is extra. We don't have 2. We only have the value of 1. So how? We must remove this 2 by it. We must eliminate by divide by 1 over 2. So now if you cancel out this 2 and 2, you will still get the same value. That is what I mean here. Okay. So now is the format is the same. We can change to, using the transform integral, we can change to 1 over 2. And then 0 to t. Okay, the inverse Laplace transform of this part, we can get the sine 2t. Okay, and we integrate the sine 2t, we obtain minus cos 2t divided by 2. The limit is from 0 to t. And substitute the value of t with t and 0. So you get minus cos 2t divided by 2 plus, okay, minus is plus with cos 0 divided by 2. So 1 over 2 this one is minus cos 2t divided by 2 plus with this one is 1, so you get 1 over 2. So now I multiply in, I get 1 over 4, or I take out the 2, I take out the 1 over 2, so I multiply with the 1 over 2 here, so I get 1 over 4. And then this one is 1, okay, this one is I take out the 1 first, 1 minus cos 2t. So that is how we solve using the transform of integral. Or if alternatively, we can use the partial fraction. Okay, using the partial fraction. One over s in the bracket s squared plus 4, we can obtain a over s plus bs plus c divided by s squared plus 4. So we move this one to the right hand side, so we obtain 1 equal to a s squared plus 4. Okay, we just left s squared plus 4. We eliminate the s. Okay, we cancel out. And then plus with bs plus c, s squared plus 4, you can cancel out, and we left the s. So a s squared plus 4a, we multiply in, okay? And then plus with b s squared plus cs. And then we collect the s power of 2. We have a plus b s squared plus c s plus 4a. So now by comparing the coefficient and solve the resulting system of linear equation, we compare s power of 2. So we have a plus b equal to 0 because left hand side we don't have anything. Okay, we don't have anything. And then for s power of 1, okay, this is we have c only, and then left hand side we also don't have anything, so c equal to 0. And then we compare s power of 0, we have the 4a at the right hand side, left hand side we have 1. Okay, left hand side we have the value of 1. So we know that the a is equal to 1 over 4. So this is equation number 1. And then I assume this one is equation number 2. So I insert the value of a, that is the equation number 1, into equation number 2. Equation number 2 is a plus b equals 0. So a plus b equals 0, then a is 1 over 4 plus b equals 0, b equal to minus 1 over 4. So now I can substitute in the equation, that is the inverse Laplace transform of 1 over s, and then s squared plus 4 equal to inverse Laplace, and substitute the value of a, that is 1 over 4, and then minus, okay, because b is the minus 1 over 4, so minus with the b value, okay, and then plus with c, c is 0, c is 0, okay, then divide by s squared plus 4. So now I simplify, I take out the 1 over 4 because it's the constant. I left 1 over s, okay, 1 over 4, and inverse Laplace transform of s over s squared plus 4. So inverse Laplace transform 1 over s, you get 1, so you remain 1 over 4. And then s divided by s squared plus 4, that is the cos 2t. So I get 1 over 4, and I simplify, I got 1 minus cos 2t. So this answer is exactly the same with the previous from the transform of integral. So this means that in order to solve the inverse Laplace transform, we can use many methods. Okay, either you use transform of integrals or you can use the partial fraction. Okay, that's all for this session.